Hi, Aidan. It's great that you came here. Why don't you introduce yourself?
Yeah, sure. Thanks, Levi, for having me. It's a pleasure to talk to you. So my name is Aidan Cowley. I'm a scientist working here at the European Space Agency, and I've been working with the agency for the last 6 years. And my background is in the area of material science and energy systems. So before I came to the agency, I also worked and lived in Ireland, in Dublin, where I did my research degree, my PhD, as well as a couple of years of lecturing and research activities. So I've been involved in science and technology for the last 15 so years in terms of development. And I've been involved, what's driven me has always been a deep interest in science, in technology, and also in space and exploration and how all these different teams connect together.
And so the work you do at EAC, the European Astronaut Center, combines both because it's science as applied to space, right? So what do you do at the European Astronaut Center?
Right, exactly. So at the European National Centre, I act as a science advisor. So my job is to help manage the centre as we engage with exploration topics in the future. And exploration demands new technology. If we're going to go back to the kind of places where we want to go explore, you need new technology and new techniques and new insights to go explore these locations. And that's kind of what my job is to look into the technologies and the operational ideas we might need to explore new locations as we go further into the solar system.
And I'm sure we'll talk a lot about those in detail. You are an expert of ISRU, in situ resource utilization. Could you tell our listeners a couple of words about what that is?
Right. So ISRU, it's a wonderful acronym. It's a real mouthy acronym. Sometimes people sometimes call it space resources as well. But basically, ISRU it's a paradigm. It's a new way of thinking about exploration. To date, most of our sojourns into space, either to low Earth orbit or even in the past to the moon with Apollo, were very short-lived affairs where we might spend a couple of days on the lunar surface or maybe a few months orbiting on board the ISS. And in all these cases, we're very much dependent upon logistical support and resupply from Earth. But the reality is, as we go deeper into exploration and go further and stay longer in these places, the idea of having all your supplies all the time coming with you from Earth is certainly not impossible, but it becomes very mass expensive. So it becomes very difficult to bring all that material with you. A better solution, we feel, is looking into finding resources that you could use locally to sustain your mission. So for example, if you're on the lunar surface, you could potentially use the material you might find there. This is what we call regolith material. It's a ubiquitous kind of sand-like talcum powder kind of material that is everywhere. And this could also be used as a resource. So for example, you could build radiation or habitation elements with this regolith material. You could even chemically attack it and actually release some of the interesting minerals that are bound inside it. So for example, the oxygen that is trapped inside this regolith, and use this to sustain yourself. So essentially ISRU or space resources, it's like living off the land. It's basically a different way of approaching exploration. And I think as we go become more and more serious about this, it's going to become more and more important in the future.
Okay, so you already mentioned how you can make habitats on the moon, for example, using ISRU and using the technologies that are already developed basically for different uses on Earth today. And ISR is also about that, right? Like taking technologies that already exist and transforming them to work on the moon. What would you say that are some of the lowest hanging fruits in ISRU? What are the first things that we're gonna do on the moon or in Mars, which fall under the umbrella of ISRU?
Right. So probably the first thing you're going to look about is, imagine if you just stepped onto the moon or onto Mars. If you're a pragmatic person, you probably want to get home. So the first question you're going to ask yourself, how do I get home? And in order to do so, you're going to have to refuel your rocket ship. So say, for example, you're on Mars and you need to refuel your oxygen and methane Starship, for example. Then in which case you'd be looking around you for resources that can refuel your ship. On Mars, then this is the atmosphere. CO2 in the atmosphere could potentially be broken down into oxygen, and also you could potentially find local water resources to give you your hydrogen as well. On a similar case on the moon, you'd be looking into production of oxygen to support your return vehicles as well as yourself. So if you're asking what the lowest hanging fruit is, it's probably production of gases to refuel your rocket. The next step from that then would be looking into, how can you, okay, you have a return road to get home, which is great. You're not stuck there anymore. The next question is, how do you sustain yourself there for longer periods of time? And in that area, I think you'd be looking into construction. You'd be looking into using the materials around you to support yourself for longer periods there as you're refueling your spacecraft, for example.
Exactly. When I asked you the question, you said the first thing you want to do when you're on Mars is go home. Well, you can make yourself a home, right? You can build a base, and probably maybe that's actually even more important than getting the fuel, because you want to sleep somewhere for the first couple of nights before you start working on your methane. The word Starship has already come up. We are only 5 minutes in, and I can't resist the temptation to ask you, do you think that this Starship is going to be the thing that's going to bring us to Mars?
Well, I think there's still a lot of questions to be addressed about the nature of Starship and how it will get us to Mars. In saying that, though, I don't think we can deny that the company behind Starship, SpaceX, have really thrown the aerospace industry around a lot and changed the way we look at things, and things that seemed impossible not even 5 years ago are now actually commonplace and happening every single day. It's become almost mundane. Likewise, the idea of reusable Starship elements, perhaps moving back and forth between Earth and Mars, it doesn't seem so crazy anymore. And as more and more of this technology gets demonstrated, I think people's confidence in these in this Starship concept will increase. And then you'd be in a situation where you're saying, actually, this does make sense. It does work. And, maybe there's some killer problems that we haven't seen yet. For example, for me, one of the problems I still have a hard time getting around is how Starship will land on the surface of Mars without perhaps creating large craters from the engines, for example. So these are challenges that have to be overcome. But I think what SpaceX have done now is open up the room to new and innovative ideas, whereas before aerospace was perhaps a little bit conservative. And in that kind of mindset, when people are actively thinking about problems and questioning the fundamentals of whether these things are possible or not, suddenly all these impossible scenarios don't become so impossible anymore. They become a lot more tractable.
Yeah, and to make it even more possible, you'd probably have to really start working on how to get that Starship fuel, because the whole point of reusability is you fly it right back. So so let's talk about the landing on Mars. We landed on Mars. Let's skip the details, like you don't have any landing pads, but where would you land on Mars? If my memory serves, like you have actually advised SpaceX on where to look for water on Mars. What can you tell us about that?
Yeah, so we weren't giving them a specific, it wasn't just me, it was other people as well. But, there has been some discussions about this. But like, for example, the question you need to ask yourself is, where are the resources, So I think you have to understand then that if you're going to land on Mars, you don't want to be a million miles away from your refueling resource. You're going to be relatively close to it. So the two resources you're going to need are obviously the atmosphere, CO2. Okay, that's fairly abundant and available pretty much everywhere on Mars. But the other one then will be liquid water, or at least water in some shape. It doesn't have to be liquid. It could be ice as well. In that regard, then there's a couple of locations where you want to be looking at the glacier fields or some of these briny deposits, perhaps, or locations where you might be able to find this resource. And that really constrains you then to a number of areas on Mars that would be interesting to land in. But you don't want to be in the driest part of Mars. You want to be in areas where you can get to your resources.
Exactly. Could you maybe name some of those places? Maybe some of our listeners know about some of the specific, craters or valleys on Mars.
I wish I could, Levi. You have me there. I'd be more than I can name many features on the moon, but not so much on Mars, I'm afraid. But if you like, I can come back to you with some names in the future. But for at the moment, I don't have any solid locations to set up base yet.
Yeah, I mean, I think it's there's a reason for you to be thinking about Mars, sort of thinking of the moon first, because that's where the European Space Agency is aiming.
So we have an exploration strategy. So we know what we're doing with regards to exploration. And in that strategy, we have three destinations. The first one is low Earth orbit. So what we're doing aboard the ISS and perhaps in the future, commercial evolutions around low Earth orbit. The second location is, as you said, the moon. So we don't say we're going back to the moon. We say we're going forward to the moon because we're using the moon in a very different way than in the past. We're not just going there for short boots on the moon. We're going there for a much more prolonged experience. And then, of course, the last destination in our strategy is Mars, which we've discussed already. The reason why we're looking a lot into the moon is because you can use the moon essentially as a kind of proving ground for the technologies you might need for Mars. This includes things like how to support astronauts for longer durations when they're no longer so close to Earth, how to deal with things like telecommunications delays, how to deal with the radiation environment for longer periods of time, and basically build up confidence in the technologies and the operation that you need to make a mission to Mars more practical and safer and feasible. A lot of the ISRU technology that we might develop for Moon as well is also transferable to Mars. So for example, if you're practicing building landing pads on the Moon, in many ways, the technology is fundamental. Same way you build landing pads on Earth, it might be the same way you build landing pads on the Moon, might be the same way you build landing pads on Mars, and you build up experience across these different destinations. So we look at the Moon as the next location only because we think of it as an ideal stepping stone to further locations.
Exactly, and one of the things that could transfer well is how to extract water ice from maybe places where there is water ice. So what do we know about water ice on the moon? It's one of the top targets, if not the top target, of space agencies and private companies alike. What's up with water ice on the moon?
Right. So, I mean, there's a couple of aspects to that. I mean, it's an interesting target because scientifically, it's got a lot of interesting data in these deposits. Where we believe you'll find water on the moon is these permanently shadowed regions. These are areas that have not necessarily seen sunlight for many millions or even billions of years, and this has led to an accretion of this water ice over time from various different sources. So this is a fascinating geological record going back billions of years unperturbed. But it's also then the second side of it, as you said, is more for the resource usage. If we know there's water there, we can get to it, then this opens up a whole slew of different applications. What do we know about it? The reality is we don't know as much as we probably like. And one of the first things we need to do is to prospect and actually to validate the nature of this resource. So if we look at what's happening with NASA, ESA, and other places, one of the things we're talking about first is prospecting. So we think there's water there. We're pretty sure there's water there. We've seen it from orbital lunar probes. We've even crashed a spacecraft into one of these permanently shadowed regions and observed the spectral response from the eject coming out of this impact. And we can see that there's water in that mixture. But of course, that doesn't tell us about what shape or form the water is. Is it it's bound as ice? Yes, but is it like giant blocks of ice that you and I would find in a fridge, or is it like loosely bound to all the sandy regolith that we mentioned before? These are questions that we have to answer and understand. Is it all collected in an area, or is it distributed much more homogeneously across a larger region? And that affects then how accessible the resource would actually be, because you can't just assume that it's there in giant, cubic cut shapes of ice that you can pull up and put into your rocket engine. That's not the way it's going to be.
Yeah. By the way, there's a long way to go from pulling out ice and actually having the hydrogen and the oxygen at the right temperature without boiling off and all that stuff. So it's still like not a settled question if that is going to be like useful industrially. There is the Outer Space Treaty. What can you tell us about that and like how that affects what you can or cannot do on the moon?
It's funny, you're the second person in the last few weeks to ask me this question, and I must read up more on it because I can't give a good answer. But it does raise an interesting question about resources on the moon, as I understand it. I don't think the legal framework for understanding how who owns resources that you produce on another celestial body has really been fully thought out, probably because no one thought it was going to happen when they were first putting together the Outer Space Treaty and stuff. I know there's people now who are talking about this a lot more, and maybe things have advanced a lot more than what I can tell you and your listeners. But as I understand it, it's a fair question at the moment. Is it whoever goes there and sucks up all the water ice? Is that the winner? Is that the way it works? Is it really a wild west up there for resources? If you start building giant landing pads all over the moon, do you own those landing pads? These are all questions that I think more legal minds than mine would have to tackle, and I think it's something that are starting to pay more attention to as space resources are developing.
Yeah, legal people or maybe even historians. I think historians are the kind of people who have the capacity, the knowledge to answer questions of like human dynamics, because I just have an inkling that it might just become the next Wild West. It's interesting how the moon is close enough to the Earth that it might be more of like an independent, like a dependent colony, so to say. Whereas Mars, if ever colonized, and if colonized in a way that it's self-sustaining, could become its own new country. Have you ever thought of like that long? Like, so what do we want to do on Mars, right? Like, do we want to just like do science, or do we actually need an extra planet to secure ourselves from ourselves?
Yeah, no, I think it's a very good question. I think it's, I told you already within ESA we have our three destinations. But then I think a fair question to ask is what happens after that, because do we just stop at Mars and say, okay, job done, and give ourselves a nice big promotion and walk away from it? I don't think that's the way humans work. I think, when we go to these locations, I think people will be magnetically drawn to them the same way that humans have been drawn to any exploration endeavor in history. So I think places like Mars will eventually start to be colonized. Whether now those will be sustainable cities like we've imagined, or if it's more just like small outposts like Antarctica or something like that, it's a fair question. But I don't think once we've gone there and made the effort to sustain ourselves there, I don't think we're ever going to go back. And I think, personally, philosophically, I don't think we should either. I think by the nature of exploration, it changes humans in a positive way. And I think that this is, where we're meant to go. We're meant to go out there and explore. So we should be, going to the moon, then going to Mars and building up capabilities to sustain ourselves there, and then going further into the solar system. And who knows after that, maybe that's the beginning of the great migration across the universe,
Yeah, I mean that there's somewhere to start, and I can't agree more with you. It's our imperative to go for and explore. I think humans are explorers. We have been exploring. We have colonized our entire planet, and we've run out of space here. I think the next adventure out there is the moon and Mars. So at this stage, like moon versus Mars, do you think that the moon will have a self-sustaining colony? There are not all the resources there that would allow that. So do you think the moon will ever truly be its own colony?
No, if you're asking me pragmatically, I'd probably say, as you said, the resource, the deficit there is too great. There's a lot of interesting materials that are present on the moon, a lot of oxygen, so you have that in your favor. You've got a lot of interesting material that you can build things with, and there's a lot of nice metals and bound in mineral form there, like titanium and iron and stuff. But you're also missing a lot of other things that are kind of critical for human ecosystems. For example, carbon. It's a fairly carbon deficient environment compared to what we're used to. And that's only starting. There's a lot of other things we're missing there as well. So I think in terms of sustainability, the moon is more of a place where we might have settlements that are fundamentally, partially self-sustaining, but would still depend a lot upon logistical support from the home planet, from Earth. I think the path to making the moon a completely sustainable habitat or world is really quite challenging. Even in the minds of science fiction, it's a challenge to make happen. Whereas other places in the solar system are much more attainable. I always like to joke that if you could do it on the moon, you can probably do it everywhere else much easier.
Yeah, I mean, I'm not sure which is easier on the moon or Alpha Centauri, but that's another question. Yeah, the moon is lacking some very, very important elements. I love my nitrogen. I love my phosphorus, and it's kind of hard to come by on the moon. And yeah, unless like there's a way to make it 100% recyclable, like everything that we do, recycle it 100%, which we do not even do on the Earth. It's kind of like a tall order. But there is a lot of things, like as you mentioned, that we can do extract on the moon, such as metals, oxygen. So let's maybe dig into some of the technical stuff here and talk about our favorite topics of how to extract metals on the moon and what we can do with the metals.
Yeah, well, this one you probably know just as well as everybody else, Levi. So yeah, the challenge is, how do you get those metals out? And when you look at the moon's composition, the one I always like to show three pictures of how you look at the moons. First, when you look at it atomically, so you see like there's lots of oxygen, lots of titanium, lots of lot of iron and aluminum and stuff. And you go, oh, that's great. There's loads of useful elements here.
Elements, yeah.
But then you step away and you look at the compounds and you see that they're not sitting on their own. They're actually bound in compound form. So the oxygen is there, but it's always like combined with something else, SiO2, so silicon dioxide, for example, or titanium oxide, and all these wonderful oxides. You go, okay, so that's a bit harder. And then the final stage of it is you look at it not just in its compound form, but in its mineralogical form. So you have your element, your compound, and then your mineralogical form. And mineralogical form, like some of these mineral names could be the size of our screen here. Like they're really long, complicated stoichiometric chemical setups. And that's when you really start to realize that this is not a trivial thing to get at those. It's not like you just go up there and scoop up titanium. You have to scoop up the mineral form of it and then break it out. So it's a little bit like modern day alchemy. You have to basically target what you're going after and try find ways of extracting that. The good news is, as you said in your preamble, a lot of what we do we can gain a lot of knowledge from what we do here terrestrially. So for example, aluminum, we on Earth have, kind of mastered a little bit the art of extracting aluminum from various different sources. And not all of them are economically viable, but some of them are quite good. And that's where we have, quite a lot of aluminum running around. Likewise for iron, it's a very old extraction process for these. So you can start looking at what we do here terrestrially and seeing what could be applied to the moon. So here on Earth, we use a lot of electrochemistry to break up and get at these interesting compounds and elements. And the same technique could be used on the moon. So you could look into electrochemical reduction of material. You could look into other reactions like pyrolysis, for example, where you literally just energize the bonds so much that they break, and you're left with your interesting compounds or gases. There's a whole range of terrestrially developed techniques that we have that essentially can be used to attack and target specific compounds and minerals and extract the good stuff that way. And the hard part is adapting them to the space environment.
For sure, and if it did work, I think it could maybe become relevant for Earth, specifically for iron extraction. Iron extraction today is done with carbon on Earth. You basically burn carbon to get to your iron ore, well, to your iron metal. But you can do it electrochemically. There was never an incentive on Earth to do that because carbon is just cheap. But maybe this technology, electrolysis, could help us actually be greener on Earth as well. So what do you think? Do you think so? These are not the low-hanging fruits, right? Like we agree, the low-hanging fruit is the ice, is why NASA is going there. Do you have like a time frame in your head? Like when do you think those gonna become viable, like even commercially viable, if ever, to go to the equator of the moon and get some titanium or titanium metal, for example?
Right. So I think it's not as far away as people might imagine. Like, so we're not talking like decades from now. Already, all the agencies that who are involved in this kind of space resources world are talking about flying what they're calling demonstrations to the moon surface and testing the technology there. So, for example, ESA is looking into one particular electrochemical process called the FFC process, and they're going to fly a pilot plant to the surface of the moon in the next 10 years. That's the plan. And they want to demonstrate that this both produces oxygen and also maybe produces metals as a byproduct as well. So this is a very unique and potentially interesting technology. NASA are also looking into electrochemical processing of the lunar soil for the same kind of purposes. So I think if you're asking me like what kind of time frame you can expect to see demonstrations, then I would say in the next decade for sure. So by the end of the decade, we hopefully see some of these processes being trialed on the surface, just to give us as engineers and scientists confidence that they're working in the way that we expect. And also we have to adapt our systems to the lunar surface. I mean, the one that we all take for granted is cooling. A big metallurgical forge here on Earth can use water flowing from a river, or even air to cool down their coke beds, for example. We don't have that privilege on the Moon. We have to be very careful in how we engineer our systems to manage that heat. Otherwise, we can destroy our spacecraft very easily. So once we get these kind of things tested and demonstrated on the surface in these demonstration capacities, then we start looking more into the applications of these products and how they can be used. So you're looking perhaps for the beginnings of commercial interest, perhaps in the 2030 timeframe. This is just speculation, but I think that's a reasonable timeframe where companies might be looking to actually put down these kind of plants to generate these resources, and then perhaps sell them to institutional actors like ESA, NASA, and so forth, or even sell them to themselves or use them for themselves. For example, SpaceX to refuel their Starships.
And there comes a question: what is now possible that Starship has gotten awarded the status of the moon shape, right? So NASA has been looking at sending the Starship, which means that you can send way bigger demonstrators, and you can send those plants way earlier. Has there been talks about like how that changes like everything that we have been like planning so far? Because now you can have like suddenly like 100x bigger reactors.
Yeah, it's terribly exciting for anyone in the space resources world. One of the big constraints is your mass. So for example, you want to build things on the moon, you're going to need things like bulldozers or cranes or something. And yeah, you can get clever and engineer really small solutions, but then you're limited to the size of what you can build. Where suddenly, if you have 100 tons being able to be delivered to the lunar surface, the sky's the limit. The idea of unloading a small bagger to go around and collect regolith is not so crazy anymore. And likewise, as you said, if you want to put down a pilot plant that can now deal with hundreds of kilos of regolith at one go, that's very much possible. Certainly, what Starship offers to lunar surface infrastructure and capabilities is deeply exciting. The possibility to have quite substantial payloads on the surface to realize these ambitions of building things and extracting resources. It's enabled by that vision, and that excites anyone who's in this area.
It certainly excites the hell out of me, and I've been thinking if something like this could be possible in Europe. Is this the one person myth, or is this the one team myth, or is it just like something that was a lucky person and a lucky time and a lucky everything? Like could Europe replicate this and make its own new young people filled startups with new rocket technology?
Well, why not? I mean, to me, I think it's a breaking of a dam. Once you break the dam, then all these ideas begin to flow out, and new companies and new startups and new initiatives within institutions can kick off. A lot of times people get stuck in an orthodoxy of how to do things, and all it takes is someone to show them that doesn't have to be that way. And I mean, all you have to do is look at the history of science to see people had, for many centuries, had orthodox views of certain things. And one person comes along, radically changes it, and suddenly there's a whole wave of innovation and creation. It doesn't have to be. I don't think necessarily the factors that led to SpaceX succeeding are just centered around the US. I think the capability for us to mimic what they're doing and take a lot of their ideas and improve upon them and make it a European endeavor is absolutely possible. I don't see a reason why that can't happen.
Okay, let me know if you have heard of any company who is thinking about these things. I'm going to be first to apply. It turns out you cannot apply at SpaceX because they only accept US citizens.
There's a couple of German startups looking into this area now. So if you keep your eyes open, I mean, startups are often stealth because of the way the institutions work. But I have heard of a few. Yeah.
I think in Germany there's at least 3 different micro launcher companies who are looking at reusability. Hope they're gonna grow in size, in the rocket size. So the carbon sequestration X Prize is this new idea of giving $100 million to the company, to the startup, to the idea that would sequester successfully carbon dioxide from our atmosphere. This is ISRU. I'm seeing there the same ideas necessary to break down CO2 from the air that we could potentially use on Mars. What do you think about that?
Yeah, absolutely. I mean, I think if you look at the history of spaceflight, there's so many technologies that we've developed for spaceflight that immediately spin into Earth applications. I mean, the one I always give, people ask like, how does human spaceflight or spaceflight in general, solve climate issues, and okay, I could point at the satellites, but that's too easy. But the one I like to point at as a materials guy is solar panel technology. This was developed for satellites and enabled exploration of space. And now we're slapping it onto the roofs of all our houses to help minimize our electricity bills. The technology would not have been developed to the point that it is now for space. A simple truth. It's undeniable. The efficiencies that led to where it is now is a function of space. And likewise with ISRU products in the future, as you mentioned earlier, we use carbon here in many of our processes on Earth because it's just bloody abundant. It's everywhere. When we're going to the moon, we're looking at different processes, and they haven't been developed as far as some of the processes we have here on Earth. Because what drives people here on Earth is efficiency with the resources and also the cost. The kilowatt hour and everything. Um, on the moon and other places, we may have to force ourselves to develop complementary or alternative processes using techniques that were perhaps discounted in the past. And simply by iterating through them and developing them, we may actually make them more efficient and then spin them back onto Earth, where now they can replace these heavily polluting processes. A lot of times it's people just go for the easiest, cheapest, dirtiest solution.
All the
Space
time.
demands you all the time, actually. Yeah, space demands you to approach this from a very different perspective. You have to be efficient, clever, think about all these other factors and your resources as well. So that has a huge potential to spin back into industries here on Earth, and it does all the time.
Mhm. You have partly answered this question already, but so what would you say to people who say space exploration is so expensive? We have enough problems to solve on Earth. What's your standard answer?
Well, I mean, I feel like I'm just reading a little bit off a script, but it's a genuine truth. I think, when you look at the value of what space exploration gives back to Earth, uh, you get the soft value and you get the hard value. The hard value is the development of technologies and knowledge that directly impact and improve our lives here on Earth. So, for example, GPS technology or satellite navigation for your phone or for your car or whatever, or solar panels that now give you, reduce your carbon footprint in the world. These are examples of hard technologies that have, a direct impact and shape our lives, telecommunications as well. These shape our lives in so many fundamental ways. But then there's also the soft power of exploration, which is that it drives people, it gives people a target, something to focus on. And in this case, I think the focus is exploration. And my perspective is exploration is a fundamental drive for humans. We need to go explore. We're driven to go to the next village, to the next town, to the next city. It's what got us out of Africa. It's what got us into the Fertile Crescent. It's what got us into civilization. And this need to go and constantly explore and develop. And that inspirational power of exploration, even nowadays, has a huge value on making people step up and actually, take ownership of developing themselves to be able to do exploration. So it leads to a new generation of thinkers. It leads to people who want to go out there and explore, like astronauts. It leads to scientists like myself who are inspired by what space could offer. And these people, return their value to Earth in so many different ways in terms of their motivation and their expertise they developed to get there. That I think that between both the hard advantages and the soft advantages, you get so much return on your investment. I think it's something that we'd be very foolish to turn away from.
I think it's one of the highest ROI, return on investment endeavors that we have, space exploration, and one of the coolest. And I think it's kind of hard that like you cannot put a number on this. Like you cannot put a number on like how many people it got inspired, and then how many people decided for scientific studies because of the love for space.
I think I did actually see a hard number for the hard value. I think I saw that for every €1 European invests into space, they make about €3 in return, and it was done some very interesting mathematics. I'm no expert on the economics of this, but that doesn't account for the soft value, which itself is geometric. Imagine people like Elon. He wants to go live and retire on Mars. Look at the multi-billion-dollar industries he's created on his way to make that happen. I mean, you have Tesla, you have SpaceX, which are now valued at something like 70 or 80 billion. You can't say that the need for exploration doesn't generate value, because it absolutely does.
Does so much. Would you go to Mars if it was a one-way trip?
If it was a one-way trip, I'd probably maybe be a bit hard pressed because I think I like exploration, but I also like my life here on Earth, and I like what we can do here on Earth. And there's still lots of things to see and do and investigate here on Earth. But certainly, if it was a return offer, I would be very keen on it.
That means that if you were the only person that you could do that, you'd definitely have to take the offer. Like if you were the one person who's left and to explore Mars, you would take the offer.
Yeah, I mean, if they need me
Even
to
on
go
a
there and
solo
push a
trip, yeah.
button to save the world, I'd go do it because, of course, that's who I am. But I'd very much like a return trip if possible. Yeah.
Mm. Hypothetical stuff. A Mars colony. Do you think? So what's your best bet? Like, what do you think is the safest time frame to set if we are looking at a self-sustained Mars colony? When do you think is it going to be 100 years, 200, 1,000 years? What's your feeling about that?
So self-sustained one is always a hard one to kind of answer. But if you're asking like when you might start seeing like significant amounts of people and kind of normalcy around traveling to Mars and living there for periods, I'd say probably around late 2040s, 2050 time frame is when you might start to see like settlement or in plural settlements perhaps on Mars. For how far they develop really depends on what technological choices we make in the near future. Because if we go down the road of just going there and spending a couple of months and then flying back without really embracing living off the land, like I mentioned earlier, then you're always going to be constrained. You'll only ever be able to live inside your bubble of environment. But if you start to use the resources locally and build up capabilities to to build up an industrial base on these planets and then build up your civilization around that, then things get interesting. So it's a hard question to give a good answer to. I would say you'd see like, uh, continuous activity around the 2040, 2050 timeframe. And then depending on what technology choices we make in the near future, you could have more sustained going forward, or it may just only ever stay at that kind of, small level activity.
I believe it's really hard to pin down a singular point where there's going to be a sustained presence on Mars. I do not think that we humans on Earth will just vanish, from one day to another. I think it's going to be more like the U.S. We have discovered the U.S. We have colonized it in a way, and we are still like in all ways like just tied with the U.S. We have excessive number of connections with them still, and I think it's going to be something like that in the future with Mars. And as space exploration and space travel is becoming even more commonplace, it's probably gonna be the same way. I think that Mars is interesting because it's our first stepping stone, maybe to the stars and to the rest of the solar system. But to me, on a philosophical note, it's important because I cannot guarantee that there's other life. There's another chance for consciousness out there to do something interesting, do something exciting, do something worth doing. And what do you think the chances of life are to exist out there in the stars? Do you think that there's life other than us?
I'd be very surprised if that was not the case. I think the nature of even if you do the statistics on the size of the universe versus other life existing, I think the answer is very, to me at least, is intuitive in the sense that life probably has to exist out there. The question that I find more philosophically interesting is what level is that life at? So we all watch Star Trek and we all see all these aliens meeting together on space stations, having good chats, and all looking roughly the same and all giving each other high fives and all at the same technology base. But the reality is, I don't think you'd ever really find that level of parity. You'd always find massive discrepancies between capabilities and where they are on their evolutionary or civilization life cycle. And this to me is fascinating. I love asking myself this question. I love science fiction books that ask this question: is if we encountered life, would we even recognize what the hell life is? Actually, just yesterday, I was sitting out in my garden, and a little like kind of grasshopper thing landed on my hand, and I just picked it up and put it gently on the side so I didn't accidentally step on it. And I kind of philosophically mused to myself: does that grasshopper know it just landed on a godlike being, and that I intervened to save its life, and it never even knew I did it? That's the nature, I think, of these different civilization tiers. They may be millions of civilizations out there, but they could be so distinct and different at different levels that we just don't even recognize what we're looking at.
If you had to bet €1,000, what would you say? Is there something like an entity, as we are to the grasshopper, so incredibly complex and just like in any ways more advanced that we don't actually even we cannot comprehend? Do you think that there's something out there?
Yeah, if I were to put money on, I would be very surprised if that was not the case. What shape or form that is, whether it's like moon-sized mega brains of silicon computer chips, or some vast distributed intelligence, who knows? It's beautiful fodder for science fiction thoughts. But I think it's an important philosophical question to ask ourselves: is what is the nature of life? What does life look like? Because you may encounter it and never even realize that it's been staring at you in the face all along. This to me is one of the more fascinating aspects of exploration.
That's what I think too, and I'll bet too that there's something like that out there, which would mean that we are in good hands, right? Because if you were so nice to that grasshopper, they're probably nice to us as well, right?
Right, but then the converse as well, just to play the devil's advocate, how often do we ask ant colonies before we build a motorway through their homes? So we just don't do it. So there is definitely an element of you can be a benevolent perspective on things, and perhaps that they don't engage with lower civilization levels for reasons. But maybe they just don't give a damn and just don't care, or it's just not in their programming to understand what we are either.
Yeah, I definitely hope they will at least keep us in reservations or national parks. I'd like to have my human adventure continue and play around with that stuff.
I think was it South Park that they had a reality TV show where Earth was the central focus for the universe. So
I don't think I watched that one. I must watch it. Yeah. I also think, by the way, that we could actually give a rise to something like a super intelligent general intelligence that could just permeate the cosmos in ways that we are not even ready to imagine. So this brings me back to the Fermi Paradox of why we do not see them. You just mentioned that they are either microbes or these godlike, space permeating super beings. Where do you see us humans? Do you think we are on track to become gods, or do we have like a major hurdle before we get there?
Well, that's a question. So I mean, for me, it's a question of I think we've reached an interesting decision point in our civilization now, because we if you go back even 100 years ago, evolution was being understood. We had Darwin talking about it, and now we're at a point where we can actually shape who we are at almost at a molecular level, which is an incredible technology. This didn't happen until very recently. So the question maybe is going forward, is that what we're meant to do? Like, is the whole point of it to shape our own evolution into something grander or greater or more capable, or are we meant to give birth to something that's more grander, more capable, more like generalized AI, as you said? This is perhaps now is the time where we can actually start asking these questions, because we now at least have the tools in our box to start maybe considering this. For example, if we go to Mars and want to live there for permanent time, going as we are now, where we're equipped for 1 g of gravity now, whereas on Mars it's 1/3 of this. Maybe that's the wrong way to do it. So maybe we start looking into 50 or 100 years from now, we look into making alterations to the people who go there, or perhaps we grow them specifically to live in that environment where they can withstand the reduced gravity and propagate and have offspring on that environment. That then is a question of directing our own course of evolution, and then maybe the end goal of it all is exactly that, where we just start moving up through these civilizational tiers until we're suddenly giant mega brains flying around in space, doing all sorts of random stuff.
Yeah, that'd be great, and it'd be great to join up back back in space where we belong, maybe in 100 years, and play some Quake. I also think that it'd be nice if we made it out there, and I'm seeing that maybe it's not up to us. Like the way you said it is, it's maybe the dynamics, right? maybe it's going to be money. Maybe we are subject to like bigger forces now. Maybe technology itself is a playbook that's telling us what to do, because smartphone, right? Like smartphones are kind of like doing their own thing. I don't think we are ruling smartphones. It's mostly like the other way around. And with new technologies, I fear like the control is slipping out of our hands, and it's just going to be what it's going to be. And but I do believe in technology, and I believe that like the more technology we have, the more solutions we have to repair the damages we've done, and hopefully it's gonna get us through the great filter and into a cool place.
Yep.
And so on the way there, we still have money, we still have our urges, we still feel hunger, and there is a lot of things that we can do with this money. So consider €1 billion. Billion as in the American billion. It's like a milliard. 1,000 million euros. What do you do with that? You get that money today. What would you do with that?
Okay, so I mean, if I got €1 billion, I'd probably be a very happy man. But if I were to use it in a more altruistic way and try to advance humanity, what would I do it for? I'd probably look at. I would take a lot of pages from what SpaceX are doing now, because I think um, their approach to reducing the costs for exploration is a critical thing. Until you make it much more affordable, there's always going to be a bottleneck there. So I really like what they're doing with their approach, and I would probably invest a lot of it into that. The second thing I would do is try set up more challenges like the one as you mentioned, the carbon capture from the atmosphere and so forth, and also other green challenges. I think the solutions to this problem on Earth are already there. So there is no radical new technology necessarily needed to solve the climate crisis. It's just a political issue. And I think that money could be used perhaps to incentivize people to make those changes. So I'd probably use it one way to open up the door for exploration, and the other way to help open up the door for people to start making the changes we need to make here on Earth.
Yeah, I think Elon Musk had something like 200 million, and he founded both companies, Tesla and SpaceX, with that. So 1 billion should probably get you to at least one big company.
I keep the 800 million for myself and buy myself a really nice house. Yeah.
You get a big house. You might even get a house on Mars with that money.
Exactly. Yeah.
Okay. Would your calculus change if I said a trillion with a T, so 1,000 times more?
Well, for that, then you can almost guarantee that you would succeed, simply because in terms of like the rocketry aspect of things, you'd probably be able to blow through so many prototypes that you would eventually crack the solution, I would hope. So it would make that prospect a lot more possible. And likewise, then here on Earth, again, with that kind of money, I don't think you make quite as much a dent as you think with $1 trillion. In the climate crisis. It certainly would be a huge help, but really the challenge here, like I said, it's not technology. It's more about getting people to understand how to use it to solve the problem. So panels, proper batteries, wind to gas conversion, microgrid capabilities. Not very sexy things when you say it like that, but these are actually proven solutions and they can be rolled out. It's just that we're so used to it, much like SpaceX were in the past, to the aerospace industry. We're so used to doing things in one particular way that it takes a lot of inertia to overcome that orthodoxy and get people to flip and start investing and changing the way they approach these problems.
Yeah, I was actually kind of surprised when NASA selected SpaceX Starship to land on the moon. I thought they were kind of locked in with the original plans and the legacy rocket manufacturers. Do you think Europe is ready for that kind of shift?
Yeah, I absolutely do. I think there's definitely appetite for it. I don't think I think people will be asking that question to European citizens will ask that question as well. Okay, we didn't invent it first, but why aren't we doing it now? And that's a fair question to ask. So I think there will be a lot of pressure on people to examine what Starship and SpaceX have been doing, and either mimic it or make our own interpretation of it, and that's perfectly fine.
To your knowledge, has Arianespace been working on reusability?
I believe so. I believe they've looked into it now and are looking into it even more. So I don't know what the timelines for that. I'm not a proper rocket scientist, but there certainly is definitely people who are looking into this now in a lot more serious. And you mentioned a couple of German startups. I think there's one or two I know of who are also looking into reusability, and that's only in Germany. I think once you expose people to an idea and show that that's not totally crazy, people will instinctively follow it. There's a reason why there's billions of different mobile phones out there. It's a good idea, but there's different flavors of it.
Yeah, the same thing with electric cars. One person needed to like produce ones to convince everybody. It's actually like a big business, and you can make your own. Same thing with rockets.
That's human nature. I mean, if you're sitting as a herd species and some guy steps out of the cave and he doesn't get eaten by a saber-toothed tiger, then maybe outside the cave's not so bad.
Yeah, I'm so glad that my ancestor did that. I'm happy here.
Same here.
Um, China and Europe. China and Europe has been collaborating in space so far. Where do you see this collaboration going?
Well, I mean, again, I can't really speak for the agency on this one, but I think as a scientist, I think collaboration across China with China is absolutely possible. It's happening. So, I mean, I know people like to draw the political headlines, but at a working level, I believe cooperation in the core areas of science and technology is happening. And I think we need to recognize that while there's the geopolitical aspect to the world, there's also a world of people who want to do better for all of us and understand our knowledge, expand our knowledge, and that level exists as well. And that level doesn't stop usually because of geopolitics. Even in the historical Cold War, like Russian Americans and American scientists were still finding ways to collaborate occasionally, and the same thing can
Yeah.
happen with China.
Yeah. Second space race. Is it looming as China's getting stronger in every way? Economically, it's inevitable that there's going to be like a second Cold War, maybe kind of. That could maybe lead to a second space race. Do you think it's coming? And if yes, do you think it's good?
I prefer not to think of it as a space race. I don't think it's a race per se. I think it's actually a new golden age for exploration. I think it's a different way of looking at things. I mean, if you look at historically, like with crossing the Atlantic and discovering the Americas and so forth, that was perhaps a little bit of a race in many ways. But after that, then once they realized that this land was there and it was available, a lot of countries embarked upon exploration of this land, and I think that's that led to the golden age of discovery, as they called it. Similarly, I think with exploration, we're entering a new golden age where the cost of doing business in space has dropped quite dramatically. The ability to get there is becoming more ubiquitous across many nations. Like so many countries now have launched their own rockets. Like you've new space players like India and even like Australia now are involved in stuff like that. So the barrier to entry is still complex, but it's a lot more achievable because it's been shown how to get there. And because of that, a lot more people are getting involved into it. So I don't think it's really a race anymore. I think it's more of a space marathon. I don't even think it's a marathon. I think it's more of an exploration golden age. I mean,
Like a
even
new
for me
gold
in the
rush, yeah.
last for the last 6 years, I mean, when I joined when I was first looking at joining ESA, the space shuttle was still flying, and reusable rockets wasn't even a talk about. And now we live in an age where you can crack open YouTube and watch a giant Starship belly flop through the air, and reusable rockets are flying back and forward all the time. I think it's if that doesn't tell you that this is a new age, I don't know what does.
Yeah, for sure. And so I see these two aspects. I do actually believe that there's going to be a space race aspect to this. I definitely see that the bigger motor to this new space golden age is new technologies. But this race aspect, especially the economic race, and it will also come down to who will extract the ice on the moon, and that might lead to some tension there. So I think that aspect of it is just human nature, I think, and it could also like lead to some positive developments, like as it did in the space race in the 60s and 70s. I have some questions about which are either overrated or underrated. So I'm just gonna toss out a concept, and you tell me if you think it's overrated or underrated. ISRU.
Underrated.
What do you think about fluorine reduction?
Underrated.
Any other ISRU techniques that are underrated, should get more attention?
Yes, I think pyrolysis as well is also underrated.
Okay. Materials science.
That's a good question. Underrated in terms of people not appreciating how deeply touched we are by materials in the world, but perhaps overrated in terms of people who seem to expect that materials scientists can produce wonder materials all the time. I always get a chuckle when I read about space elevators and the tether material that they're meant to make it out of. It's like, if you can make that material, then more power to you. But as a materials guy, that's an impossible challenge.
Okay, let's stick with this one because I thought we have already found the material, and it's called carbon nanotubes.
Yeah, but sure, and you can spool like a couple of meters of this stuff, or even longer sometimes. But like the idea of being able to, you know, and also carbon nanotubes are very strong in tension for sure, but their sheer strength it can be quite weak. So yes, you might be able to produce a tether that can go to orbit and hold something in orbit, but then you also have to deal with all the other problems that a tether might have. For example, it's going to be friction with the atmosphere. It's going to be exposed to micrometeorite impacts all the time. So eventually that material is, all satellites will crash into it. Um, um, so that material has to be able to withstand, 28,000 kilometer plus impact velocities from random pieces of crap in the solar system,
It's a
as well
very
as in low
thin
Earth
thing.
orbit.
It's got a very like slight chance of that happening.
It's not as chances it's not as small as you think. I would encourage you and your readers or listeners to check this up, but eventually a depending where you put your space elevator, it'll be coincident with every point of that orbit. So any space junk you have there will eventually potentially impact with your tether. And how do you survive a multi-thousand-kilometer-per-hour impact with a
Okay.
material? Yeah.
Okay, that's a mental note to myself. A smart ISRU guy is a hater for space elevator. Okay, have to look into
No,
this and then
I'm
run
not.
run the numbers.
I love those ideas, but I am a deeply pragmatic person, so I hate doing this to people. But when you see silly ideas being parroted around too much, you have to kind of stand up and tell them, invest your efforts elsewhere, guys.
Okay, I will actually like run the numbers and like calculate the probability of an impact of any object, right? Because
Good news. You can you don't have to run them. You'll find plenty of papers out there on this. So
okay, interesting. Okay,
some people like to turn a blind eye to the bad news.
um, university studies.
Underrated. I think university studies are a critical part of developing your critical and thinking acumen. And an educated mind is an open mind, and an educated mind, as my father says, a piece of paper that you get at the end of it, it's very easy to carry, and will open up many more doors for you, I believe.
Having kids.
Ooh, that's a good one as well. For me personally, I'd say probably a little bit overrated, but it's a personal decision. I think everyone has to respect that. I got two cats and I love them, and so does my wife, and we're happy to stay with that. I don't think it's for everyone, but that's my perspective. Yeah.
Liberal democracy.
Underrated in the sense that people take it for granted. And I don't think people appreciate how much the Enlightenment and the values that have flown from the Enlightenment have shaped our world in the last 100 or so years. And a lot of that is driven by the fact that the technological development is very much tied to liberal democracies and their existence. The ability to freely share and express ideas without any fear of censure from your government or from other parties is a critical element of scientific discourse. Uh, all you have to do is look at Galileo and how he said the world or it was not the Earth's not the center of the universe anymore. Radical idea, got him in a lot of trouble. If perhaps the church had won that battle and silenced him, how far back in history and understanding would we be?
Probably in the dark ages still. Um, our duty to our parents.
Definitely underrated in the sense that I think we should always look after the people who supported us in a time when we couldn't even support ourselves. But I do appreciate that not everyone's family situation is perhaps peaceful or as enjoyable as my own. So some people are very happy to escape and live their own life, which is perfectly fine too.
Cultural differences.
So how do I answer this now? Overrated or underrated? I would say it's a bit of both actually, because I think people overrate the cultural differences and use them as a force for division, when I think they can actually be a source of strength. And I think sometimes people underrate the value of having different cultures involved in teams. I think it's very important actually to have different perspectives. Otherwise, you get into kind of groupthink, cultural groupthink, and that can lead you into very strange, orthodox places too.
For sure. Adventure.
Highly underrated. I think adventure is a critical thing for expanding your horizons. And I always like to cite Plato. I think it's Plato, yeah, Plato's allegory of the cave. That when you step outside the cave and you see that the light that was dancing on the wall was actually caused by something else, and you see the bigger world around you. I think this is an important part of why we should adventure and explore. It expands your horizons and expands your perspective.
Couldn't agree more. Hedonism.
Hedonism, definitely overrated in my eyes. I think excess is a dangerous thing. I look at the world in terms of consumerism, for example, and perhaps it's gone too far in many cases. How many versions of a phone do you need? How many versions of a car do we actually need? I certainly agree some variety is great, but perhaps too much of something is also a sin.
Courage.
Courage can be definitely a little bit underrated in my books. I think perhaps it's always difficult to step outside the crowd and do something in a different perspective. And be the first person to do something is always a challenge. But we should always try to drill ourselves that this is an important part of being human, is to be courageous and step out and be brave.
Honor.
Definitely also underrated in my eyes as well. It's important that you have standards that you apply to yourself and to what you expect from other people. If you don't have a kind of baseline metrics for how you judge your own capability and your own ability to engage with others, then I think you're in a bit of a strange place.
The last one is kind of a complicated one I have to explain. Building big and useless buildings. What I'm thinking about is like the Eiffel Tower, or like big monuments that are like by design are useless, but stand for something, stand for like a bigger idea. Do you think we should have those or not?
Yeah, I think there can be value in those things. I mean, our if you look at our Neolithic ancestors, they built a lot of crazy things that were often just there seemingly for unusual reasons that don't stand up against time, but do give us interesting insight from the future, looking back into what they were thinking at the time. So even with the Eiffel Tower, it allows us to understand, the exuberance of France at that time in terms of where they were coming from. And I think perhaps at the time you might look at them and go, this is a statement to folly, but we have to remember that we write our history for the future generations too. And that perhaps these things are things that we do not so much for us now in the present, but maybe to inform people in the future as to what we were thinking at that time.
Yeah. So, would you be down for building something? And if yes, what would you dedicate it for?
Actually, I saw an idea from the artist in residence at ESTEC, our technical center in ISA, a couple of years ago. He had an idea for a moon temple. The idea was to build a temple on the moon. Now, I don't agree with the religious aspect of things, and that's not what he was going at. But the idea of perhaps a statement for what we as humanity represent at this time, and to build something there that could last for billions of years, because the moon is, well, most of the time it's pretty devoid of many, it's not, it could potentially be a nice time vault for the future is what I'm trying to say, or even put something into deep space that maybe other civilizations might find. So if something did happen to us, at least we've made a statement to the universe that, we were here. This is what we thought of in 2045 or whatever. And I think there's value perhaps in that. There's a great episode of Star Trek where it's called The Inner Light, Star Trek The Next Generation, where a civilization created they knew they were on their last legs and they had nothing left to do to save themselves. So they actually built a probe and sent it into space. And eventually this probe was picked up by the Enterprise, the Starship Enterprise, and was able to convey to to one of the crew members on board the experience of being in that civilization in the final days of their world. And I always think that's a beautiful sentiment to perhaps monumentalism.
Yeah, that record, the golden record on the Voyagers, that's I think one of our biggest accomplishments ever.
Right. I
Um,
totally agree. I think there's value to making statements for the future.
um, so there are three more things here that I would like to ask you. First of which is cryopreservation. Have you ever thought about this, and what do you think? Is it useful? Would you do that?
Yeah, actually, believe it or not, there was actually a team within ESA who looked into this. So there's a team called the Advanced Concept Team,
Oh yeah.
and I think they looked into human hibernation and how you could actually potentially, use this for long duration space flight or to protect the astronauts against some perhaps from the radiation environment. And I think they had some really interesting. I can't remember the exact results, but I read through a lot of the stuff that they produced, and it was really fascinating. Um, I think one of the interesting questions about cryopreservation actually is that maybe there's a deep link to our ancestral DNA going back or many generations, even to different species. That maybe hibernation is something that is actually endemic to mammals, and that we've just as humans forgotten how to do this. And maybe there's a way of triggering it, perhaps. In which case, then maybe like hibernation is not such a crazy idea. It's just something that we've evolutionarily turned off, and maybe it could be turned back on. In which case, then you know, long duration missions to other parts of the solar system might become feasible.
Or even beyond the solar system. So
Or beyond.
would you get yourself frozen if it was for free? Let's imagine it's for free, and you're on your dying bed, right? So would you get yourself freeze in the hopes that maybe in the future somebody will discover a cure for your death?
Yeah, I mean, I probably wouldn't pay for it, but if it was a free service and someone said we can do that for you, I would actually have no problem. For me, that's a zero sum equation because I'm, probably dead anyway. So either way, if they can bring me back, more power to me. But if not, I'm dead. So
Yeah. I mean, I think to me it's positive something, right? Like especially if it's free, right? Like you can get to see the future or even get to immortality. I'm one of those guys who believe like maybe there's actually a chance for us young people to live into the technological era where there's immortality invented. What's your odds for that? Like, what do you think is the percentage chance that we will invent immortality before we die?
So I love this question. I'm actually okay. I'm trained as a material scientist, so I'm not much of a biologist, but I do follow the discussions around longevity, and I've reading up a lot on it over the last decades. I think it's a fascinating question. I think I don't think the jury is quite in yet on whether it's possible, but certainly it seems like there's certain tricks that you can do to extend and prolong your life. Um, Immortality in your current format probably not really feasible. Not only if they could make you biologically immortal, then that's great, but like something else is going to kill you eventually. So it could be a bad day, you're going for a cycle and then something just happens, or you get hit by a meteor. There's just acts of God that simply cannot be uh, mitigated against. But biological immortality, if you're asking me about that, then I think it's maybe not as crazy as people think. I also think it's an area of science that should be funded more because uh, forget the immortality aspect, but every one of us get old, and if we can minimize the impact of getting old on our families, on our society in terms of cost for healthcare and everything, then this to me is a very valuable investment. If you can live a really good life up until the very last moments of your life, then this reduces the cost and burden on society, and it feeds into saving the world from an environmental perspective too. So for me, I think it's an area that's underfunded. I think there should be a lot more work done in it. It's deeply interesting. It's a question that we should perhaps always be asking ourselves, is it possible and whether it can be
I
made
think
happen? Mm.
more people should be talking about this, and maybe that would even render us more longer sighted, right? Because if you live for maybe 1,000 years, you might be thinking harder about what you actually do today, to kill your environment or pull some CO2 out of the atmosphere.
Yeah. If you have to live through the effects of what we're doing now, you might appreciate it very differently. Yeah.
Um, Smartest people alive in Europe. Do you know of like extremely smart people who are alive in Europe today that I could maybe go and talk to and ask some real deep questions?
Yeah, I mean, I know lots of really smart people, I hope. One of the privileges of working where I do is you get to surround yourself with very clever people and very dedicated. I also know a lot of good scientists from my old life back in Ireland who are really interesting and dedicated and super smart, way smarter than I am. People and you can learn a lot just by pure osmosis, just by being around them and listening to them talk about stuff. You just get smarter by proximity, which is awesome. So yeah, I mean, there's definitely lots of people. I think maybe we are a little bit too driven by the popularity aspect of things, where you need to have a big name, like like uh, Richard Feynman, or uh, you know, I'm trying to think of, you know, Einstein, where there's like, brilliant minds, but there's science. One of the things I love about science is that there's a whole army of foot soldiers who are brilliant foot soldiers who do so much work, and each one of them is brilliant and fascinating to talk to in themselves. Maybe the light doesn't get shown on them all the time, but that's not a failing on them. That's just because the way it works sometimes with the lottery of popularity. But there's lots of really excellent, brilliant, genius level people running around Europe doing amazing stuff for all of us.
Yeah, and I think the will to be famous is inversely correlated with the smarts sometimes, and sometimes their smartness will catch up with them, and they will eventually just become famous. But yeah, do you think you could like name some who might wanna who are underrated?
It's a good question. I'd have to come back to you on that one. I don't have an answer for you live, but I'll definitely give you some thought and come back to you. Yeah.
Please. Um, so if you have maybe another 10 or 15 minutes, I have some extra questions for here for you. So this would be reactions to my theories. I have some pet theories that I think are kind of controversial. So I'd like to know what you think about the inevitability of climate change. We could, of course, pull the CO2 out of the atmosphere at some point. Is it going to be ever feasible or commercially viable? Is another question. It's kind of inevitable, right? So climate change is going to happen, and that's my tenet. And as much as it's real, I'm not sure that's anything really to do about it. At least, like not today, because we are doing this on a global scale. What do you think about it?
Yeah, I know there's a certain nihilism that you can attach to this, that you feel like there's nothing you can do, but the reality is I think there's still lots of things we can do. I still think the decarbonizing our energy grids and moving to more sustainable systems for our societies is really important, because even if we can't stop the temperature rise immediately, we have to remember there will be follow-on shocks to our societies that come from the effects of this temperature rise. For example, mass migrations, or redistribution of water resources and everything. So the more you can make your civilization and society more robust with technology now, it's an investment in the future, if you ask me. So you may not be able to stop the 2 degrees or 1.5 degrees change. I can't remember what exactly the IOC is saying now. ICC, sorry. But that doesn't mean you shouldn't not be making as many changes as possible to address that problem, simply because I think that's an investment in the future.
Okay, but so you agree that there's nothing that you can do about it. You can change something on the margins, right? Like,
yeah. I'm sorry. So I mean, well, I'm probably not super qualified to answer that absolutely, but I do think there's a feedback, response. So it takes time for the system to respond, and the planet is responding to the inputs we're giving it now. So perhaps even if we stopped all our carbon pollution tomorrow, you might still get warming for a little bit of time, simply because of the way these feedback loops work. In which case, then technically, yes, I guess you're right in the sense that maybe you cannot directly stop some heating happening. But you can mitigate against what comes next, and even then stop it becoming a bigger problem in the future.
So start slow, start small, and then maybe make it bigger later. Another thing I already talked about is how I think that maybe money itself can become our next evolutional driver. So as we have come out of the caves and we have become who we are, it was a lot about our political systems and a lot about like our capability, which moved us further. And I'm seeing that maybe money itself could become the next civilizational driver, and money itself can buy, like these days, popularity and power, and I really think that like we have come into this like loop where I'm not sure if there's like a way out. I'm not sure if there's any way for humans to get back behind the reins of our own destiny. What do you think about that?
Yeah, well, I mean, money can certainly be a positive thing and a negative thing as well. So it really depends on how it's used. I mean, it's a fundamental ideology for how capitalism works in terms of distributing resources from location to location and so forth, and services. Um, it has a lot of negatives, but it can also, in the right hands, it can also be a very positive thing. And I think the fact that even in the last 100 years, like the general median standard of living has risen, is probably largely attributed to the fact that now that money allows the distribution of that wealth, that resources, to more people. So there's a hugely positive example of money. It's raised us out of dark ages to where we are now.
I
Going
definitely agree with
forward,
that. Yeah, so I don't doubt that. Actually, I think money is usually doing positive things, right? Because money usually does what people want it to do. But there are these new inventions, global corporations, and with global corporations sitting on so much money, I think there are different dynamics that could come alive and like start to dominate. And the way that governments used to be a relevant factor, maybe corporations can become like the next relevant factor. And if corporations are running on money returns and on profit, then obviously money is also gonna buy us like space flights and the new solar panels, but increasingly it's gonna just buy its own power, just try to like concentrate itself to defend itself from the human will is how I'm seeing this.
sure, but maybe you're anthropomorphizing corporations a bit too much. You have to remember that while they have characteristics that are perhaps attributable to a psyche and a persona, they're fundamentally made up of humans, and we're all part of a society. So how we incentivize our society is how those corporations will fundamentally shape. So if we all suddenly, tomorrow woke up and decided to become crazy, super hyper environmentalists living in trees, then the corporation that sells Hondas doesn't have a market anymore, and it ceases to exist. So there is a people power element to it here that we should never forget. That fundamentally, the basic building block of our civilization, of our society, is the person.
Yeah, and I certainly believe that we will always have that, or we will always have like a sufficient amount of that to counter the rise of the big mammoths.
That
So what
ties
I'm
into the
saying is like,
question about education earlier. You were asking about universities, because the more educated and critically thinking people you have running around, the easier it is to shape that society in a way that you want.
yeah, but you're using the services of Amazon and Google and Facebook. You're not trying to like feed the mammoth, and you're a smart guy.
Yeah.
And so yeah, I'm not sure what Facebook and Google is going to become, but so I'm seeing this like you said, I'm personalizing this, or like humanizing. I think I'm thinking of these organizations more as like an ecology, like a system of like a newly emergent life form, in which the survivors are the ones who are the greediest and who are able to like generate the more money. And historically, it's been correlated with like how much value they produce to shareholders and to people. But I'm seeing like increasingly it's becoming correlated to just how much they can game the system and not pay taxes, and like make monopoly situations for themselves. Which so I think I see those two forces stacked against each other, and in the first lines to watch who's going to win, because I like my liberty. Another one is consciousness. Consciousness, I think, is simple. I think a lot of people think a lot about consciousness and how we could maybe one day decode it. And another one of my pet theories is that consciousness is actually simple. Something like consciousness is here and here and here and here in your brain. and it's just this and this and this, interactions between those brain areas, something like that. And it's tempting to think about consciousness as something magical because that's the only thing that we know about for sure. What's your theory about what consciousness is?
Okay, so it's a really interesting question. So my own subjective perspective on it, and this is not necessarily based in what the current science literature might say about it, but for me, feeling it's I feel it's a kind of a phenomenon that arises from a whole bunch of different characteristics. So I also have a feeling that only a suspicion, a feeling that it's probably very linked to fundamentally how the universe is structured from a matter perspective. So I think there's perhaps an element of quantum reality to go what's going on here, and I think it's uh, maybe something that even with crazy technology in 50 or 100 years from now might still elude us in terms of understanding what it is. I think it's much in the same way that we can describe the famous Young slits experiments where you can see light as both a wave and as a particle. It's both. You just have to accept that's what it is, but you try to explain it away and try to go into too much detail from that, it becomes incredibly difficult. You just can't do it. You just have to accept a certain fact. So maybe we have to say to ourselves that consciousness is perhaps a fundamental element of reality, in that whenever you have certain organized matter, that it is an intrinsic property. And it could be just like a combination of quantum systems coming into effect. Who knows? And again, this is not borne out by any literature, by the way. I'm just giving you a subjective brain dump of how I think about it. I think this is actually fascinating, though, because if that's what it is, if it is some fundamental property of organized matter, organized in the sense that organic and think, or organic and biological or so forth, then that opens up a lot of implications for the nature of the universe.
It does, and well, the question is does it have to be biological, or is
No.
this mostly about information processing? Like, is the internet in a way conscious? How do you see
Yeah,
it?
I mean, that's what I was saying there. That's why I was trying to correct myself, because a crystal is a structured piece of, but I don't think a crystal is looking at the universe in quite the same way as you and I are. Maybe it is, and we just don't know. That could be a hilarious thing. Um, you know, it could just be like a weird resonance of matter that we're all on the same guitar string and we're being strummed and we're just oscillating at different frequencies at different points on the string. Um, Maybe that's what it is, but I have a feeling it's a very fundamental question, and I think it has a lot more. I don't think it's just like transistor chips, mimicking certain things. I think it's a very deep connection to the universe, and I just don't think we're ever going to necessarily. At least I can't see an easy solution to it just yet.
Mm-hmm. I really like what you said, that you believe that this is something that as soon as enough matter comes together, it just kind of emerges, and the more matter comes together in the more complicated ways, that the more of it is present. I'm a materialist, and I think that there must be a way, like a mathematical way, to describe it and to have a formula for this. But yeah, it remains to be seen. But if there's something like the solution to the consciousness, I think it's gonna be pretty easy and pretty simple and like kind of dumb, and but still fascinating in here.
Yeah, but I mean, this is the kind of great questions to ask. I mean, this is what drives science forward. Is if we don't know something, we just start, trying to deconstruct the problem and see if there is a solution. Maybe it's just fundamentally, an unsolvable problem. Like the young slits, you can't be two things at once.
Yeah, and I'm looking forward to like see the day when this gets solved, because I'm gonna pop a champagne that day. All right, well, Aidan, these were all the questions I want to ask you. So I'm really glad you did this, and I'm super excited to edit this and get back to you.
Thanks, Levi. It's been a pleasure talking to you on this very diverse and interesting range of topics, and I hope it's of interest to your listeners too.
I hope so too. And if you feel any day like getting back on the Quake train, me and my good buddy, we're playing Quake 3 CPM. That's a Challenge Promote Arena, and it's really like the cool thing going on in the Quake space now. Let me know. I can dump you a link, and
That's good to know. I'm going to work on my gene editing of my eyes, so I have this like wonderful ability to see everything just as mouse cursors, and then I'll be able to play, no scope railgun shots across the map. Yeah.
Yeah, I'd love to learn that one day. All right.
Yeah.